Do you know that companies such as Google use binary search to make your search faster? So today we're going to take a look how to code binary search in Python. Hi, my name is Art and we're doing practice Python problems and efficient solutions here at Robotic View. So let's talk about binary search. That's my favorite searching algorithm, and it's also very fast. So let me show you how we could actually write that code. But before we get to actual code, let me tell you what the algorithm is about. I'm going to use a simple example, and I hope some of you still remember that long time ago we had all phone numbers in yellow pages, and then there was the other one, white pages, where you can find phone numbers of people. Okay, so now suppose my goal is to find the phone number of Michael Jackson. Yes, I'm a huge fan. So I could use actually binary search. Keep in mind that binary search could be applied only to sorted array, and it's got to be sorted in ascending or descending order, or in alphabetical order, speaking of white pages. So the algorithm goes like this. I take white pages and open it right in the middle. Okay, what I see there, M. And I don't care about second half of the book because I know that J's got to be before M, right? So I immediately don't care about second half of the book. So I take the first half of the book and open it again right in the middle. And then I see G. And I know that J should be after G, so I don't care about first quarter of the book. So I have left with a quarter of the book, so I take that book, open it again in the middle, and then bam, I see J and I see Michael Jackson's phone number. So that's pretty much how that algorithm works. Now let's try to code this algorithm, but first let me walk you through the algorithm one more time. So here I have an array of numbers, right? 10, 20, 30, and so on. So maybe my goal is to find if 30 in that array. I want to find that 30. Is it in there? So that would be the question. So how this algorithm would work? So first I need to find the midpoint. So how would I find the midpoint? I know that the starting index of an array always 0, right? So 10 will be 0. Then I know that the last index would be what? Would be number of items in that array minus 1. So then it would be what? Then it would be 1, 2, 3, 4, 5, 6, 7 minus 1, 6. So index of the last cup or the last item would be 6. And how would I find the midpoint? I need to take starting point, which is 0, plus 6, which is the index of the last item. So I'm gonna get 6 and divide it by 2. But I'm going to be using floor division, because as you remember, floor division always returns a whole number, because I don't want to get 3.5, right? So for example, I don't want to take 7 divided by 2. I don't want to get 3.5 because there is no 3.5. So in this case, one more time, I take positive index of the first item, which is 0. I take index of the last item, which is 6. 6 plus 0 is 6, divided by 2, 3. So you see, midpoint I could find midpoint by index 3. So then I need to take that value or that number or that item and compare it to the value that I'm looking for. So if that's the case, if they the same, so then we're done and pretty much algorithm stops and we answered our question. However, if midpoint is not the number that I'm looking for, then I need to decide which way I need to go, left or right. So what I mean by that, I need to understand if the value that I'm looking for is greater or less than value of a midpoint. In this case, we're looking for 30, so obviously 30 is less than 40, so what we would need to do, we would need to take midpoint and decrease index, and I want to underline that, index of midpoint by 1. And that would be our new end point for that new array. So we don't care about all numbers that would be greater than 40, right? So we don't care about those numbers, we could just remove them. And now we have a new array which is 10, 20, 30. So then the algorithm repeats itself, so then I need to find a midpoint. So how would I find a midpoint? The index of midpoint will be 1. How do I arrive at 1? So starting point still will be 0, and then new endpoint would be what? Would be 2. 2 plus 0 will get me 2, divided by 2 will get me 1. So new midpoint I can find by index 1. So then again, I need to check if that value of midpoint is the same as the value of the item I'm looking for. And as a matter of fact, no, it's not. Now 30 is greater than 20. So since I need to go right way now, I need to adjust starting point. So how would I adjust starting point? If I know that midpoint index of 20 is 1, I need to add 1. So 1 plus 1 will get me 2. So then 2 plus index of endpoint, which is 2. So 2 plus 2 will get us 4. And then, since we're looking for midpoint, we need to take that 4 and divide it by 2. So 4 divided by 2 will get us 2. So 2 would be new index of a new midpoint. So then I grab that value by midpoint by that index of 2, and then I compare value of that item to the value that I'm looking for, and perfect match. So bam, we're done. And that's pretty much how you do binary search. Alright, let's write some Python code, and first I'm going to define my list numbers, and here I'll use same numbers as in my slides. So suppose I have 10, 20, 30, 40, 50, 60, and then 70. Alright, then I will create target. So target will be number that I'm looking for, and I'm looking for 30. So again, question is, I need to answer a simple question as true or false, is 30 in that list. Alright? Okay, so how we're going to approach this one? So we need index and we need to find the midpoint, right? So we need to find the midpoint. So in this case, I'll define as start index. I specifically want to use that word index, so I want to make sure that you understand that starting point, I go by index, would be what? What the index of the first item in any sequence, it is 0. So then end point index, I also want to go by index, I'm sorry, I will use underscore index. So then it would be what? How do you find the positive index of 70? So you need to take length of that numbers, and that would get us what? 7, and decrease it by 1. So that will get us 6. So 0, 1, 2, 3, 4, 5, 6. You see, so that will be my end point. Then I will create a variable name called found, and found will be false. Why false? Because I have not found anything yet. right? So if I find that 30 in numbers, then I'll change value of found to true. Now in this case, we're going to be using while loop. Why we're going to be using while loop? Because if we use a for loop, then we would go through each item in that list numbers, and we don't want to do that because we want to go a little bit faster. So while, and remember, while loop, it iterates till condition is true. So I want to create condition that at some point will be false, because we need to get out of that while loop. So first thing first, could there be a case that there is no number that we're looking for in that list? Yeah, that simply could be the case. So for example, if we're looking for 35, then 35 obviously wouldn't be in that list. Okay, so then I need to think of that too, and I want to say if start index is less or equal, because there might be just one number, and index. So that would be my first condition. And then I want to use found, but I cannot use found because it's false. With the false, my while loop will not run. And so then I need to flip that condition temporarily, and I'm going to say and not found, and not found. So that would be my condition. All right, so I want to make sure that number that I'm looking for in the list, if number that I'm looking for is not in the list, I want to get out of the while loop eventually. And second condition would be if this is true. So simply I'm flipping false to true. All right, so then midpoint, and again let me remind you that midpoint represents an index. So how we're going to find it? So we will take that start index plus end index, right? So start index is 0 plus 6, so 0 plus 6, 6, and then we use floor division because we got to make sure that we're going to get a whole number, so divided by 2. So that would be my midpoint. All right, good. So then remember what algorithm says. We need to find a midpoint, and we need to check if that value of that midpoint would be equal to our target to 30. So let's do numbers and apply that midpoint, and then we need to check if that's the target that we're looking for, and obviously that's supposed to be an if statement. If that's the case, so for example, if we were looking for 40, so because 40 would be midpoint, then we would be done. Yeah, 40 is 40, so then bam, you're done. So then I would take this found and I will flip it to true. Yes, we're done. So if that was the case, then this condition would not be true anymore. That would be false, and that will take you out of the while loop, and then you're done. However, in our case, we're looking for 30, and then we need to identify, because that's not the case. So if else is not the case, if is not the case, so then else. Now we need to see if our target is greater or less than the value. So how we're going to do it sounds like another if and else. If target, all right, and target is 30, less than number is midpoint, if that's the case, so then what? Then remember we need to adjust and, because we know index of 40 is 3, so we need to take that 3 and decrease it by 1, so we need to adjust and index. And how we're going to do it? So it will be midpoint and end index are indices, so -1. However, if we were looking, let's say, for 60, for example, then obviously 60 would be greater than 40, so then we would need to adjust start index. Okay, so how we're going to adjust start index? So then that would be case for else. So that would be else midpoint +1. Because we know midpoint, which is 3, so if we were looking for 60, so then we would need to adjust that index, and that would be 4, right? And then, since we're in the while loop, so the algorithm will keep running till this condition is true. Till this condition is true. At some point, we're gonna get that 30, and then this condition found will be true, so we will be kicked out of this while loop. So let's just see what found will be. And found would be true, you see? So now we get this true because we're looking for 30. Let's play with it for a second. How about what would happen if we were looking for 35? Keep in mind we don't have that number in our array of numbers, so if you rerun this, that would be false. You see, that would be false. What if we were looking for 70? If we were looking for 70, that also would be true. So binary search would be faster than using a for loop, and that's pretty much it for binary search.